Hello everyone, this is Nilesh Gule. Welcomes you to this class on solid principles. So what is solid principles? Before I tell you what is solid principles, I really need not to tell you that solid principles is one of the most important interview question, irrespective of whether you are absolute beginner, whether you are the experienced one. By the way, solid principles are basic design guidelines for the writing object-oriented programs to make your application code more extensible, flexible, and understandable. This is not really the new principles altogether. They were formulated long back in year 2000 by Robert Martin, and still they are very much relevant in day-to-day software programming, and they are very much relevant into the interviews. Before I just get into the talking solid principles in detail, I just want to make it very clear that this particular class is not teaching you what is class or object or how to do inheritance, polymorphism, composition, and so on and so forth. We are not talking about abstraction, encapsulation, because all these things, these are absolute fundamentals and these are basic prerequisites of this class. If you do not have the object-oriented programming experience, or you do not have heard of these abstraction encapsulation kind of terms, I strongly recommend go to the description box, find out the relevant links, learn these topics, and then come to this solid principle class so that you can actually appreciate what solid principles is. Now, how exactly we are going to learn these solid principles? One common approach while learning solid principles is to take principle one by one, define it, and give a short example explaining each one. And that is the way most of the people learn it or even prepare it for interview. But when you really go for the real application development, do you really feel that people are using these principles one by one or only two or three principles? You'll find that in any good size project, all these solid principles, they work together. And that is the reason I'm going to take a bit different approach. Instead of talking about principles one by one, I'm going to start with one simple mini project. And in this mini project, step by step, we will start uncovering these solid principles. I'm sure you will appreciate this particular one. Another thing, as we are going to talk about these solid principles in a practical manner and with one mini project approach, I'll be typing all the code in front of you step by step. You can expect this particular session to be a bit longer. But I request you, have a little patience, go through this process, do this programming with me, and then you will be absolutely comfortable, absolutely confident about solid principles. At the end of this class and doing all these practicals with me, afterwards you read any document or any concept on solid principle from any book or internet, I'm very sure you will be able to appreciate what exactly it means. So we will go with this a bit different but more practical approach. And then people have next question. So we are going to do the practical in which programming language? As I said, solid principles is guideline to write object-oriented programs. So any OOP language should be absolutely fine. So you can have C++, Java, C#, Python, JavaScript, or any other language of your choice. As far as this video is concerned, I'm going to stay focused on the C# programming language. If you want to implement it into any other language, please go ahead, give a try. If you have any questions regarding even that language, feel free to post your question into comment. I will try to answer. So the question is, what exactly mini project we are looking for. So here is a simple project on food ordering system. And you know that typically order placement is like selecting menu item, calculating total price, applying discount, process the payment, and then send a notification. It is straightforward process. We will try to implement it in this particular project. I just want to make it very clear, the focus of this whole application development is not to build a food order system in a real world, like with the database or like a front end or kind of REST APIs or desktop based application or mobile application. But the focus over here is to learn OOPS in its right spirit, in the solid way. And that is the reason we are going to get started with some very basic, and we will going to make a very basic console application. We will have maybe fixed menu items with the fixed prices. We can have the menu item selection from the user, or even we can hard code it. We will apply a very basic level discount logic, payment processing logic, and fixed notification to get started with. And as we will progress, we will start extending our application. One by one, step by step, we will learn the solid principle one after another. Another approach that I'm going to follow in this plus series. You do not expect me that I'm talking about some solid principle and then implementing it. In fact, we are going to do it reverse. Let us start developing something. Let us develop it, analyze it, and at the end, probably we name it, oh, this is nothing but called as a S in solid, or this is nothing but you call it as O in solid, and so on and so forth, right? So I'm sure you are ready for this food ordering system. We will get started with the Visual Studio. Just to make your life simple, I had created one solution and one file, which is very basic Hello World application, which is currently in running. And to implement this, we will start with some absolutely naive approach, absolutely beginner level approach. So to place an order, all I'll do is that class food order service. And we can write a simple method, maybe place order. We will implement everything into the same method, like let's say select items. We can have calculate price, then apply discount, process payment, and send notification. Everything at one place, just absolute beginner friendly approach. Now, in order to have the item selection, we will also consider some quantity associated with that. For that sake, I'm looking for having a small structure or class, let's say cart item. And this cart item, we will have some name, and it should have some quantity. Okay. Now, let us begin with selecting the items. As I said that you can take the values from the user. You can make it more flexible. To get started with, I'm going to keep it fixed, hard-coded. Let us select only 2 items for now. So items, and this is the array of 2. Now in this array of 2, let's say first item is pizza, and quantity is equal to, let's say 1. If we can have another item, let's say burger, with the quantity, let's say equal to 2. That's it. Let me put a simple message. Let's say item selected, and I put it items.length over here. Great. Now you want to calculate the price. As I said, we will work with some hard-coded prices. Let's consider that pizza is of 200 rupees and burger is of 100 rupees. Now to calculate the price, let us begin with some total. And then for each item in the selected items, one by one, we will add it into the total. Let's say cart item. If item dot name is pizza, total is equal to quantity, and let's say rate is 200. Else, if item name is equal to burger, as I said, let us consider the rate is 100. You can keep extending this particular menu with the additional items if you want it. Let me print the total. Good. Now I want to apply the discount. Let us have some very basic level logic. Initially, consider discount is equal to 0. And if the total is above 1000, maybe we can apply 10% of discount. Let me print the discount over here. Now, the actual final bill, let us calculate that. So amount is equal to total minus discount. Let me print the final bill amount as well. Let's say amount is over here. And then you look for processing the payment. As I said, we will keep it hard-coded for now. Let's say string mode is equal to card mode, or we can have, or let's say UPI mode. So if mode is equal to card, let's say payment received of rupees so and so, payment of rupees received by card. Good. Else, similar logic, we can apply it for UPI. As we'll go ahead, we can add the further modes like cash mode and other options. Now to send a notification, let's put it very simple. Let's say sending SMS. Let's talk about like order placed. You can put a thank you message and so on and so forth. That's it. How do you call it from main? So calling it from main should be very simple now. Food order system. And there is only one method called place order. You just run your application and then you see all the steps are gone one by one. Like items is selected, total price is this. Of course, no discount over here. Final bill is 400. Payment is received by card and sending SMS. Everything is good. Well, now the question, what exactly you did it over here? Let us try to understand. What we implemented is a single class doing all the functionalities. And many times such class is referred as God because God can do anything and everything. It is a single monolithic structure with all functionalities. Is it good? This can be good for some very basic level application or simple prototyping where you are testing something. But this is really worst when you are going for the production code, because this code is having multiple unrelated responsibilities added into one class, into one method. You find that all these features are directly coupled with each other, tightly coupled with each other. And then if you want to modify any one functionality, it will have the direct impact on another. There is no separation of concern. So is it problematic? It is too much problematic. There are so many limitations. You cannot test the individual functionality. The maintenance is really tough because finding a bugs and fixing bug is going to be really tough job. The reusability of the code, let's say discount logic or let's say payment processing logic, if you want to implement it at some other place, you cannot really reuse that. And then adding some new functionalities in future is really tough job. So the question is, what should be done next? Let me try to decompose this whole big logic into small functions. As I said that we are not going to the final solution. We will try to implement all these solutions one by one, step by step, and where we can understand how we are evolving our applications with the solid principles. But before that, as I said, let us try to break down this whole big logic into the same class, but into the multiple methods. Maybe we are doing it a bit more readable. How we can do that? Let us get started with having these cart items. Let's say I will declare it as a private member. Okay. And then this selecting items logic, we will write it in a separate method. Let's name it as select items, and it will probably return me the items. Let us go down and implement it. We can write private cart item, select items, and the above logic, I'm just pasting it over here. Let me return the items from here. Good. Let us apply the same stuff for the next, where we want to calculate the price. Again, let me put it in a separate method. I want to write the method, let's say calculate price. I'll pass the items and I will get the total from there. Okay. By the way, Visual Studio has got one feature. It can create a method stuff for you. So you can simply generate the basic method, which is, of course, it will be empty. And then I can paste my logic over here. This total calculated over here, let me return it from the function. That's it. Let us apply similar stuff to the apply discount. Again, let me copy this and write the method apply discount. Let me generate the method. Let me paste it and finally return the discount. Good. Now it's time to calculate the bill. Yes, bill calculation, we will have it over here. And then I want to do payment processing. Again, let me put it all this logic of payment processing into the separate method. Let's say process payment. And finally, I want to send the notification. Good. And you find that this particular place order method is just calling all my individual logic one by one. Great. Let me run this. And you again see exactly same output. By the way, what exactly we did it over here? By decomposing the whole logic into multiple functions, right? So let me show you over here. Here we have bind the data and methods that operate on the data in a single unit. We have restricted direct access to the internal data or behavior. Have you noted that all these methods, select item, calculate price, and everything, we made them as a private methods, correct? Because we do not want to make it available to the end user directly. End user means some person from my team, he will only call the place order, and the place order will internally call all these methods one by one. So what are the improvements we did over here? Logical grouping, like related operations are grouped in the methods. Again, the internal details are hidden from outside by making it private, our data as well as the functions. We have provided the controlled access to our data, and we made our application little more readable. The place order code is now little more understandable. Yes, definitely, this is a better organization of the code. And you'll find that the complexity, that whole stuff that we have added into like a single method, we have just made our code little more readable, little more debuggable. By the way, don't you think that still all your functionality are into the same class? So you are practically still in the same God class. Still, there is a limitation of reusability of that particular logic somewhere else. So the question is, what next can be done? How we can make this application more testable, more understandable, and further, if all developers are going to work in like a single class, it is going to be all the time full confusion, lot of conflicts. So it is really good idea, really great idea that all your logics, individual logic, you separate it into multiple classes instead of just separating them into multiple methods. And as you start implementing into the .NET in production environment, you always create the separate file for each class so that the multiple developers can take ownership of their own classes. As far as this particular demo is concerned, I just want to keep it very simple. I want to do all the changes into the same file. I want to write all code into the same file. By the way, I can definitely go ahead and modify this block code and convert it into the multiple classes. But I thought that let me keep a copy for you. So instead of like doing the changes in an existing one, let me comment out them and I will maintain this block copy for your reference so that when I publish this block code on Git, you can check from there how step by step we evolve this whole code. So as I said, we will divide our functionality into multiple classes instead of multiple methods. How we can do that? Let me have, of course, the first class we already have written, let's say cart item. Let it be there. And then I can have next class, let's say item selector, which is actually doing a job of these item selections. How? Let me write the method of select items into that particular class. Good. Since we want to call this method outside that class later, you want to make it public or give appropriate access specifier like internal. Then going ahead. The next we are looking for the price calculation. So let me have another class called the price calculator. And we will copy the method of price calculation from there. Let us also make display method as public. Then going ahead, we are having the next class that is applying logic, discount logic. So we have a discount logic. Good. And then we have the payment processing. And finally, what we have is sending notification. So I'll have notification service. Now, let us try to call all these methods over here. And of course, for that, we need to have the objects of them. So let me go ahead and compose all those functionalities into my food order service one by one. The first one is item selector service. The second one is price calculator service. The next one is discount logic service. The next one is payment process service, and then notification service. That is good. And then let me call all of these methods one by one. The first one is item selector. The second one is from the price calculator. The third one is from the discount logic. The next one is payment processor. And finally, notification sender. And you still find that in main, we are only calling the same place order method. No change other places. Let me just run it once again. The result has to be once again absolutely same. No worries. But what exactly we did so far with this? What exactly we did so far? Let us take a look at. Now, instead of doing everything into the God class, we break the functionality into multiple classes. For each class, we try to give only one functionality. Now, if you want to do any changes related to payment, you will only modify the payment processor. If you want to do any changes into the discount, you will only modify the discount logic class. There is no need that you keep changing your entire code at once. This particular principle is called as single responsibility principle, which is nothing but S in the solid principles. It says a class should have only one reason to change. So each class should have only one responsibility. The basic idea behind this single responsibility principle is separation of concern. Each class will handle only one task. And then each class focus on the single responsibility, only the relevant work. Do not try to mix up the unrelated work into one particular class. And then you can change one functionality irrespective of other functionality. You can maintain this application better. You can find the bugs. You can fix the bug without touching the other classes once again. You can reuse the same class into some other application as well. And most importantly, as I said, all our classes will be written into the multiple files. Now you can work in a team. You can do the parallel development. Your one colleague is writing maybe discount logic, while other colleague is writing the notification service. And this sort of implementation is absolutely feasible. Still, I see that this is not exact single responsibility principle, because if you go to this block code, you will realize that the payment processor class is kind of responsible for card payment as well as UPI payment. And in future, if we add cash payment or net banking payment, so everything will get added into the same class. Eventually, the class will become bulky. And if certain functionality or certain policies change for the card or UPI, you need to come and modify this particular class. So don't you think that ideally even this particular class can be broken into multiple different options? Well, answer is yes. So how exactly we can upgrade our code? Let me again comment this code and then we will go on to the next part. So according to the single responsibility principle, what we'll do is that instead of putting all functionality into the one payment processor, we'll break it into, let's say, card payment processor and UPI payment processor. So we will have a functionality of, let's say, card payment processing over here, which is only talking about the payment using card. right? On the similar line, we will have another separate class talking about UPI payment process. Well, this is done. But now either user may choose the card, user may choose the UPI. So I need to provide the options over there. So instead of creating only payment processor, let me create card payment processor, and let me also create maybe UPI payment processor. And then depending on the user choice, I can select either card or UPI as of our requirement. So I will still have the mode over here. Let's say card. Good. And then if mode is equal to card, then I want to create the object of card payment processor and use that payment process method. At the same time, if mode is equal to UPI, maybe I want to use UPI payment processor and then its process payment method. All good? Great. Let us try to run this application and check if this is working now. Let me run it. Oh, that's great. Still, you are able to get the payment by card. Let me just have a quick change from card. If you are taking it from the user, and let's say user has entered UPI, you'll find that the same code is now getting the payment received by UPI. So we have done it better. 100%, this is following single responsibility principle. But now there is a catch. In this particular code, you'll find that this card payment processor or UPI payment processor, they handle some low-level functionality. Talking about how exactly the card payments are done or how exactly the UPI payments are done. In future, if there are any policy changes into the UPI or card, the respective classes will be modified. At the higher level, the food order service is going to talk about that how exactly the payment should be done, when exactly and how much payment is to be done. So based on the user mode, we are selecting the payment processing over here. So the achievement we have over here is in this particular code, we had done the separation, but my high level code is directly dependent on the low level code. High level code food order service is directly dependent on card payment service as well as UPI payment service. And at runtime, it need to choose, okay, whether I need to go for the card or the UPI. This is really violating one of the principle from the solid. And that principle is called as a DIP. So what is DIP? The high level modules should not depend on the low level module. In fact, both of them, high level as well as low level, both of them should depend directly on abstraction. I repeat once again, in my case, high level logic is food order service and low level logic is card payment process and UPI payment process. And then high level is directly dependent on low level. There is direct dependency. There's a tight coupling between high level module and low level module. In future, if you want to add maybe the cash payment processor, you need to again modify my food order service. Yes. And then this really violates the abstraction because high level module knows everything about the low level implementation. And that makes your testing really complicated, especially for the higher level components. This makes your design quite stubborn, and this particular system is not that extensible. But the question is, how do we improve on that? As it clearly mentioned, high-level module should not depend on low-level module. Rather, both of them should depend on abstraction. Do you recall how exactly the abstractions are done in OP? Yes, abstraction can be done by using abstract classes or interfaces. So let us go a step ahead, and instead of directly using card payment processor or UPI payment processor, let me try to put it into one interface. So let me have a general interface. Let's say interface payment processor. We can also follow .NET naming convention, let's say iPayment processor, and we will have the method, let's say process payment. We can have our class inherited from iPayment processor. We can have another class inherited from again iPayment processor. And now this particular class food order service need not to be dependent directly on card and UPI payment service. Instead, it will have something called iPayment processor. We will just have a simple payment processor. Initially, you can even keep it null. That's good. Now, in this particular case, we can write one constructor. And in a constructor, we can pass this payment processor system from main. So payment processor is equal to processor. Also, let us not keep the responsibility of selection to the food order service. We do not really wish that every time adding a new mode, we need to modify that food order system again and again. So this selection logic, somewhere we will move it into the main. Over here, we will only make a call to the payment processor dot process payment. Just keep it very, very simple. And then inside main, we can have that mode selection. If the mode is equal to this, we can create the payment processor. Let's say, for example, iPayment processor is equal to new card payment processor. Otherwise, if mode is equal to UPI, we will have processor is equal to UPI payment processor. And then whatever processor is created over here, let me pass that processor to the food order service. Now let me run this, and you will find that yes, the payment is received by UPI. You can go ahead, you can do the changes into the mode is equal to card. You can try to run it once again, and yes, this is again showing you that payment is received by the card. Means both the functionalities are working very well. And in future, if you want to add a new payment processor like wallet payment processor or cash payment processor, you need not to modify your food order service or, for that sake, any of the existing classes over here. This is nothing but how we have handled DIP. DIP over here is dependency inversion principle. So let me take you over here, which is saying that our high level and low level, both modules are using the abstraction payment processor. But do you know that this particular code also opens our another principle from the solid, which is nothing but OCP, open close principle. Now, in this particular case, we can always add a new payment processing without modifying the existing classes. The OCP stands for our software entities should be open for extension but closed for modification. In other words, you should be able to add new functionalities in your application without modifying the existing written pieces of software. So this particular code has done definitely better things. The first one, abstraction. The interfaces are defining the contract, where low-level components are implementing the contract and high-level components are using these contracts. Extensibility, new methods can be added. The clause for modification, the food order service uses interface, not exactly the concrete type. And that is the reason any new changes need not any modification inside food order service. And we can always add the new functionalities in the existing application. However, if you notice the code inside main, don't you think that this code inside main is tightly coupled with your payment process selection? So in future, if you added any new mode, what exactly you need to do? You need to actually modify this particular code once again. So do we have any further improvement possible in the existing application? Answer is yes. What I suggest is that instead of putting it all this logic inside main, we will have a separate class who is responsible for actually creating the object of the required payment processor. Well, how we can do that? Let me take you to another class. Let us call that particular class as maybe the payment processor provider. So I have the payment processor provider, and this particular class is responsible for creating the new payment processor. For time being, I just make the method as static so that I can call the method without creating the object, and this will return iPayment processor. I just say create. I can pass the mode over here, and the logic that was written inside main will be actually shifted to this. So let me put it logic over here. In this particular case, depending on the given mode, I want to return either card payment processor, or I want to return UPI payment processor, or you can add the further processor methods over here. For time being, let me return null if the mode doesn't match. Let us call this particular method from the main. So whatever hard coding we have done it over here, let me remove it from here and let me call the method payment processor provider dot create for the given mode, and let me rerun the same application. Wow. And this is again giving me exactly same answer. But now my main is not responsible for doing the payment selection. Instead, that responsibility we handed over to another class like payment processor provider. Yes, this particular class I need to upgrade every time I want to add a new payment processor. However, we can definitely improve this using some configuration based settings or something called as a dependency injection frameworks that we will try to cover into some other video later. But at this moment, this particular application goes really to the next level. Let us take a look at what exactly we done over here. In this particular application, we try to apply open close principle as well as dependency inversion principle in a better way. So required implementation of payment processor is provided by a separate class, and we call it as a payment processor provider. And then that particular returned processor we have already attached inside our food order service. So our DIP is fully realized and our OCP is at the better stage. Here we have achieved the abstraction dependency. We have achieved inversion of control, means the food order service is not now directly creating the required payment processor. That job is handled by the external provider class. The dependency injection, whatever payment processor is created, it is attached to food order service using the constructor. And then we have our food order service kind of decoupled from the actual payment processor implementation over here. This brings a lot of advantages. Now, my each payment processing can be tested separately. We can have the flexible way of changing the payment modes on the fly. And then there is no need to change any code inside food service whenever my payment logic modifies. But now, after talking about the single responsibility principle, dependency inversion principle, as well as open close principle, it's time to upgrade our application to the next level. Let me talk about one more functionality. Let's say I want to add a cash payment processor inside the same application. Now, I'm very sure you people have realized that I need not to do much. Only thing I want to add over here. Let's say this is cash payment processor, and you are saying that the payment is received by cash. By the way, let us consider that we have one constraint. Let's say that the amount more than 500 cannot be accepted with the cash. Now, how we can implement this? Maybe we can think of adding one check over here. Amount is greater than 500. Then let me simply throw the exception saying that not supported exception. That's it. We keep it very, very simple and very, very straightforward. Now, can we make this cash payment processor instead of our existing payment processor? Let us give a try. I will upgrade my provider class. Else, if the mode is equal to cash, then return new cash payment processor. That's it. Now, I want to make a call to this. Let's check whether this will work well. Currently, it is working well with the UPI. Oh, that is wonderful. And I want to modify it and check if I can make it work with the cash. Let me run it. And you find that, yes, even cash is working well. But have you noted that currently our final bill is only 400 rupees? What if I just change the number of pizzas from one pizza to two pizza? Now what will happen? You will see that suddenly our bill will increase beyond 500 rupees, and that will create a trouble for me. You see that it is giving me not supported exception, saying that what exactly problem that this particular stuff is showing to me. Let me tell you, this is telling you the next problem in our solid principle, and that is nothing but LSP. LSP stands for Liskov Substitution problem, which is telling that the objects of superclass should be replaceable with the objects of subclass without breaking the application. Now, what we did, we simply added one cash payment processor, and this cash payment processor I'm trying to use in place of my iPayment processor interface. And moment I try to use that, what is happening? In certain cases, my application is failing, and this is nothing but violation of LSP. This is giving you a kind of unexpected behavior. It is not replacing your derived class straightforward to the base class. This is the violation of your contract. This is not really expected. So the question is, what should be done? I would say that in this particular case, if you want that LSP should not be violated, you should have done a better thinking while you implemented the interface. Which interface? iPayment processor. In iPayment processor, we try to make it very generic, just adding one process payment method. And at that time, we never thought that there can be certain limitations in some of the subclasses. So it's time that we need to go back and enhance our abstraction, enhance our interface. So let me just go back and talk about, let's say, iPayment processor adding one method, let's say CanPay. Let me pass some amount and let me first ask that payment processor, are you able to handle this particular amount? And if yes, then and only then we should process the payment. I guess this is a better abstraction, and this keeps the scope of implementing different policies for the different payment processors in future. But don't you think that right now adding one method over here will actually force to modify all my subclasses? No worries, that is the reason the default method implementations are provided into C# or kind of a Java kind of languages. And let me provide the default option to be true. That is the reason now card payment processor or UPI payment processor, by default, they will get the true implementation. And as far as cash payment processor is concerned, it should go ahead and it should implement this CanPay method. We know the condition. If the payment is less than 500, it will work very well. So let me simply return the amount is less than or equal to 500. I will return true. Otherwise, I will return false. This is how the method can be implemented. Now, since we have modified the abstraction, the using class, the high level service class will also need to be modified. And we need to call our payment processing method on a conditional basis. So let me go to this payment processing logic. And over here, let me write something like this. If the payment processor can pay this amount, then and only then try to call it. Otherwise, just put a simple message that this payment cannot be done. That's good. Let me try to run the application once again. Now what do you see? Instead of failing drastically at runtime, it is giving me some simple message showing that this payment cannot be done. However, if I just replace it with the, let's say, UPI or card, the same code should work very well. So what exactly we implemented over here? The earlier code, it was violating LSP. In this particular case, we have honored LSP by enhancing our interface with explicit constraint. Over here, we have added the constraint like CanPay. If the amount is less than 500, then it will be paid using that payment processor. Otherwise, you can look for some message. Of course, you need to modify your client code, your higher level service code. The client has to check the constraint before processing it. And then there is predictable behavior. It is not going to throw the exceptions at runtime. Since the contract was written in a way people can expect, the high level code can expect that these checkings are really required. So this is how LSP can be achieved. Now, any payment processor can be used interchangeably at runtime. There's one misconception people have with this demo. The people usually ask, does it mean that we should go and modify the interfaces? Please mark my words. I was not saying that you should go and modify the interfaces. Interfaces are ideally immutable. I was saying that when you design the interfaces, when you design the abstraction, at that time, you should keep LSP in the mind. And you should design the abstract classes, or you should design the interfaces in such a way that in future, any subclass should be able to easily replace those interfaces or those abstract classes. That is the reason I was trying to tell you, it is no point in like learning each solid principle one by one, because in the real world application, you have to use all these principles together, and sometimes the line is really blur, that somewhere the same code implements DIP, at the same time that code implements OCP. At the same time, you are doing abstraction, and then sometimes that abstraction need to be enhanced if you want to make the room for LSP. Great. So far, we talked about the SRP, we talked about the OCP, we talked about LSP, we talked about DIP. Now it's time to go one step ahead. And in the next step, I want to upgrade my notification service. So let us take a look at our notification service code. In this notification service code, whatever we have written, we have kind of hard coded that we want to send SMS. But don't you think that there can be different requirements like sending SMS, sending email, or maybe push notification to your mobile application? So how we can implement it in right sense? Well, here also we can go for a kind of DIP. DIP means we can have a kind of abstraction, and that abstraction should be used so that at runtime you can decide whether what kind of notification to be done. And that gives me idea, like let me make one interface. Let's say iNotification service, where we can have a simple method, let's say send SMS. We might have the additional method, let's say send email, and we might also have another method, let's say send push. Great. And then like a notification service class can have the full-fledged implementation, means it will have iNotification service and it will provide the method, let's say send SMS. It can also provide the method, let's say send email, and it can have the method, let's say send push. And all these methods are ready to send the notification. That is good. Now, as far as we have modified the interface, let us use the interface into the higher level class instead of low level implementation details. So for time being, you can consider using iNotification service over here and creating the object of all notification service. And then you can think of calling the method, let's say send SMS, or you can think of calling, let's say send email, and then you can have even send push method. Let us take a look at whether this particular code is working well. Right now, you will see that yes, you are able to send the SMS, email, and push, all three things. But what if I do not want to implement a kind of all notification service? What if I want to implement only the SMS notification service? If I want to implement only the SMS notification service, how exactly this can be implemented? Let us give a try. Let's say SMS notification service inherited from iNotification service, and then you will write the method send SMS. Yes, it will be sending SMS. Let's say order placed, thank you. Yes, that kind of message I can add it over here. But don't you think that since this particular class is inherited from the interface, it has to implement all the methods? So only one method implementation is not enough. I have to implement the send implement method and send push method as well. Currently, I can just keep these below methods empty because in this SMS notification service, I want to send only SMS. Of course, I am forced to implement the email. I'm forced to implement the push, but there is no code for me to write down there. And that is the reason I'm just keeping these methods as kind of an empty method or one which is throwing the exception. Now, can I straight away replace our all notification service with the SMS notification service? Answer is no, because moment you do that, the SMS will be sent, but while sending email or push, it is going to throw me exception once again. This is the real catch. Now, over here, what is the main problem? The main problem is again a very bad design of the interface. This particular interface is having the method for SMS, email, and push. And then every implementer class is forced to implement all these methods, even though those methods are not relevant. So you see, this particular principle is referred as ISP, Interface Segregation Principle. Ideally, the clients or implementers should not be forced to depend on the interfaces they do not use. In my case, the SMS service is forced to have implementation of email as well as push, which is really irrelevant for that. Now, this particular problem comes from the fat interfaces. The interfaces having all unrelated methods, and they are forced to be implemented into all derived classes. Now, the derived classes can probably throwing only exceptions or doing nothing. Now, this is an unnecessary burden to the clients, the methods that they do not want to use. And this makes my implementation polluted. A lot of unwanted functionality is added over here. This is error prone because runtime exceptions can be generated from your code, and that is really again the poor abstraction. The question is how it should be handled. As the name says, interface segregation principle. Putting irrelevant methods into one interface is a bad idea. Now, instead of doing this, can't I have the separate interfaces for this? Can't I make like a SMS notification service separately, which is having only sending SMS method? You can have email notification service separately, which can be sending only email, or you can have another push notification service which will send only this, so that the class which want to depend on SMS will have only one send method which is sending SMS, and it is not forced to implement the email and push as well. Now the class which want to depend on the SMS will be only using SMS. Like for example, you can put it like SMS notification service, and it will only rely on the SMS part. It will not be forced to go for the email as well as push notification and so on. Let me just comment this particular class for time being, and I will come to this after executing this. Let me comment this. Let me run this application, and you see that yes, SMS is sent perfectly. If some service want to implement only email, then it will only use email notification service, only implement that send particular method, and then only email will be sent. So you are trying to keep the implementations lightweight. Only the relevant functionalities are implemented. You might have a requirement where a particular class want to implement all of them. There's no worries. All you can do is you can have a class implementing SMS notification service, as well as push notification service, as well as email notification service. So you can always write a class which is implementing all these three functionalities. And then if you want, you can have the common implementation for all these three. Let's say sending SMS also, sending email also, and sending push also. So if you want, you can again go with this all notification service, which will actually send all these three things like SMS, email, and push. So what exactly we did over here to solve this ISP problem? What we did was writing the small interface. We have written a separate interface for SMS, email, and push service. And then the required class will implement only the required interface. It will not be forced to implement all the functionalities. So this is focused interface with only relevant method. So client specific dependencies, the classes implement only the needed interface. There is no force implementation, no need to throw the exception. So far, we talked about all of these solid principles. We talked about single responsibility principle, which says one class, one responsibility. Then open close principle, open for extension, close for modification. Liskov substitution principle, subclasses should be substitute for the superclasses. The interface segregation principle, the many client specific interfaces better than one combined general purpose interface. And then dependency inversion principle, where both high level and low level classes depends on the abstraction. Yes, these solid principle provide you guideline to think in the right spirit for writing object-oriented applications. But let me tell you that this doesn't solve all your problems, because these solid principles are guiding fundamentals. As you started writing this code or like other code, you will be facing many more problems step by step. And then these are the common problems faced by the many developers. This is where these developers, some senior developers, they come up with some good solutions, some well-known proven solutions. And those proven solutions are nothing but design patterns. In our next class, we will be focusing on design patterns, how design patterns can solve the further problems in object-oriented software development. I'm sure this particular session on solid principles gives you clear idea about the solid principles and how to implement them practically, how they are related to each other. And now when you read the definitions or when you face the interviews, you should be finding yourself more confident with this. Thank you very much for listening so patiently. See you in the next session. Bye-bye.